So developing Android apps has always been a hard task for developers. If you have been developing Android apps, you understand that you have to understand a lot of things. For instance, to build a very simple Android app, you have to understand XML, because you use XML to create that user interface, and then you would use Java or Kotlin to create the logic that then connects to that XML, and then which is the user interface, and then magic happens. Well, it's not all magic, because you know there's more to that. You know that you have to understand the Android APIs, the SDKs, and a lot of things that you need to know, or at least learn, in order to build Android applications. And that's how we've been doing things since Android started. This is what we call an imperative way of creating mobile applications. Now we have a newer way of creating Android applications, which is the declarative way of creating Android applications. And you've heard of Flutter, you've heard, if you're an iOS developer, you've heard of Swift UI, you've heard of React Native, you've heard of all of these other tools that were created that kind of shift the way development in general has been done. You see that the industry is moving towards a more declarative way. What is this declarative way of building an application? As the name implies, is declarative, which means you don't have to specify the steps on how to build a button per se. You just declare how you want the button to be shown. And so it's a different way of thinking about creating mobile applications, and that's the direction we're going. All right, so if you're new in this channel, my name is Paulo Duchon. I'm a developer, mobile developer, Android developer, and a teacher. So I teach people like you how to build apps, how to program, and how to think as a programmer so that you can become a well-rounded developer. What is a well-rounded developer, you may ask? It's a person who not only understands how to build or how to code, but also understands the other things that you need to know in order to become a solid developer. In this video, I just want to talk a little bit about the shift in the paradigm when it comes to building Android applications in particular. So we have Jetpack Compose, this new toolkit that allows us to build user interfaces, native Android user interfaces, without having to put together the XML files to create a user interface and then have Java or Kotlin to then interact with this user interface to create the app and blah, 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 and all this moving parts. Because if you look at the way we've been building Android applications, you will notice that there's this tendency of having a lot of code. Boilerplate code, which is in many ways it's just distracting and it's garbage. And so you end up with this massive repo, this massive code base that most of it's just not doing much. It's just garbage. I'm sorry, no, that's a little bit harsh. And so the declarative approach, especially using Jetpack Compose, it kind of gets rid of all of that. Now we just have Kotlin. You do have to know Kotlin, of course, but it's easy. And you use Kotlin to write code, to write user interfaces, to write Android applications. And it's really amazing, and I've been working with it. It's great. It's great. It really is great. So I'm very excited to start looking at the patterns in the industry, where things are going in terms of how apps are being developed and how developers should probably start thinking about. The great news is I'm going to show you how to build an Android app using Jetpack Compose and the basics of Jetpack Compose, so that you can see for yourself how awesome this is. And so, well, enough talking. Let's go ahead and get started. So to understand the modern way of building Android applications, we need to look at Jetpack. And what is Jetpack? So Jetpack is a library of tools to help developers build modern Android apps. The most important thing is that when these modern apps are built, they must follow the best practices. So that's the whole idea behind Jetpack. So when you hear Jetpack, you're talking about ways to build robust Android apps that are flexible, that are adaptive, especially nowadays with a plethora of different Android devices, but following the best practices. So the idea is to reduce boilerplate code and make sure that there is a consistency across Android versions, because as you know, Android is very fragmented. There are different devices, different versions, different manufacturers, and so forth. And so to have some sort of a holy grail, per se, of how do we structure our Android apps, how do we build our Android apps, to have this consistency, it's very, very important. And of course, that leads us to follow best practices. So Jetpack library has a lot of types. So here are just a few types we can find. So there are graphics, navigation, which allows developers to have a more consistent and a more consistent across the board way of navigating users that are using their app. Okay, life cycle, user interface, which is a big one. We have media, we have security, data, as well as performance and test. So these are just a few types of library that come with Jetpack. So the Android team, with a lot of experience, they had to come up with something that is more uniform as Android is growing, as the differences in devices also is growing, and the whole industry in general, development industry, mobile industry, is evolving. So they had to come up with a solution, at least close to a solution that could unify the way Android developers develop applications. So this course is going to focus on Jetpack Compose. So what is Jetpack Compose? Jetpack Compose is Android's modern toolkit for building native UI. UI is user interface. So Jetpack Compose again goes back to that main reason that we have Jetpack, the libraries, right? Which is to write less code with powerful tools, and also that will accelerate development. So the idea is to minimize the work involved in building Android applications, really. But not just building Android applications, but building applications that with less code, and applications that are consistent with the ecosystem, Android ecosystem, and so forth. That's what Jetpack Compose brings to us, a modern toolkit for building native UIs. The great thing about Jetpack Compose is that it uses not only a separate set of Kotlin APIs, application programming interfaces, so essential libraries, but also uses traditional Kotlin's libraries. This is really important because not only can you use the set libraries that are for Compose, written in Kotlin of course, but you can also use Kotlin APIs in general with Compose. It's really, really powerful. Now, why Jetpack Compose? That's a very good question. The industry is changing, but let's talk about this. Now, Jetpack Compose is a huge shift in Android development because now we're using what they call declarative UI versus the imperative approach. Now, what is this imperative approach? Well, the imperative approach is what we do, what we've been doing so far in Android development. Okay? And truth be told, it is too complicated the way things are or the way things have been done. Too complicated because there are a lot of moving parts. For instance, the UI, the user interface, is deeply coupled with the logic and vice versa, which brings a very inflexible ecosystem. Coupled means that there is no separation between UIs and the logic. So there is this very togetherness that is not healthy per se, which makes for very inflexible code. For example, one of the examples that we have to render, for instance, a list with a few items in traditional Android development, you will need to create a recycle or use a recycle view, which is a very complicated class. And this recycle view will need an adapter, because adapter will know exactly how to position the items inside of this recycle view. And these items that we're putting inside of recycle view, which need adapter, these also will need a view holder, which is a pattern that allows for the recycling of each item that is shown on the screen. So this is actually a simplification that I'm putting here together. But even though there are 3 steps that we need here, it's very, very complicated. In fact, if you have done traditional Android development, you will attest that this indeed gets messy. That's the imperative approach. This is just one example among many others. But with a declarative approach, in this case Jetpack Compose, things are different in that they are simpler and more efficient. So no more boilerplate code. Right? Because now what we're doing is we're declaring or describing in code what we want to see and not describing every step to get the result. For example, to render a list with a few items, this is the same example we had previously, right, in the imperative approach. In Jetpack Compose, all you need is a lazy column. That's it. Because now we're just describing what we want to happen. We're not going through the process of describing every step to get the result. Lazy column is the equivalent in this case of a recycle view we saw previously, without all of the jargon that we have to know and we have to implement ourselves to get things done. That is a new way of thinking about creating Android applications using Jetpack Compose. So if you're familiar with the imperative way of creating Android applications, this will be very, very familiar to you. So in traditional Android development, to create user interfaces, we use XML, right? And then we connect the XML to get the actions, right? Using an activity, Java class or Kotlin as well, right? And of course, that's the only way we are actually able to create that application. And then so that the user can start interacting with your application, and the activity has the logic, and the user interface comes from an XML file. So with our new way of thinking of creating applications, Jetpack Compose, that is no longer needed because now we have this declarative UI approach of creating user interfaces, in this case also applications, Android applications. We talked about declarative UI approach. Well, this is what it means. So this is how you would declare a user interface. As you can see here, this is what we call a composable function. A composable function will compose, as the name implies, some piece of a user interface. So in this case here, if you were to read this, it would make sense. First, we are saying we want a card. We are not describing how to create a card. We're just saying we want a card, and we're going to pass a few things inside of that card. Well, this card is going to have a column which will contain a text. Not only text, but it will also contain an image inside of this column, right? And of course, there's some logic that we're doing there, that we're making this column clickable. And when this column is clicked, we want to toggle between a certain state, expanded or not expanded, right? So even if you've never seen this code before, never even looked at Compose, this should make some sense, right? We have a card and we have a column. Inside of the column, we are describing what we want. We want an image and we also want a text. This text is going to be animated at some point, right? Because I see there it says animated visibility. That means it's going to be toggled between on and off depending on whether we have clicked the column or not. That's it. This is what we call declarative UI approach. And this is how it's done with Jetpack Compose. And that's what we're going to be focusing on in this course. I hope you're excited to learn more about Jetpack Compose, as excited as I am, because I'm so excited to show you around. And all right, I'll see you next time. Let's go ahead and get started and create a brand new Android Compose project. So open Android Studio. You can go and say File at the top. There are different ways to create a new project, but this is how I'm going to do it. And then we're going to have to get the empty compose activity. So click on that. I'm going to say next. And here we're going to create the project. I'm going to say, give it a name. I'm going to say Intro to Compose. So we're going to start from the beginning with Compose. So dissecting the major components of a Compose project and a Compose application. So whatever you want, you can name it. And of course, for a package name, mine is pre-populated with this package name, but you can choose whatever you want. And make sure you have a location where you're going to save this. So I do have a sandbox Android there in on my machine. Make sure we have Android Kotlin. For minimum SDK, I'm just going to go higher. Doesn't really matter at this point, but let's go to 10 or 30. I'm going to go 30 at this point. All right. Let's say finish. And so it may take a little while for the project to be created. So be patient, wait until the process is done. And you can always see at the bottom here what says Gradle, configuring projects. So the Gradle, which is the machine, quote unquote, that does all the work in the background to validate, to put together the entire project, works in the background. So give it a time and it will be done soon. Okay, after a few moments, you will see that our project has been created. and all seems to be good. Let's go over what we are seeing here. So to the left here, you will see that we have our Android project. The great thing about Android Studio is that it gives us different ways to view our files. So if you click at the top here, you can even change the view of your file. So you can go to project, we'll just show the project view, which means you'll have to drop in and look for files and so forth. Okay, that's a choice, but I liked the Android view because it just focuses on the files pertaining to the application. Okay, so you can also toggle it to close and open, right, the project tab here. And inside we have a few things. We have the manifests file, we have the manifest folder there, which has our Android manifest, and then we have the Java folder here. Okay, it's kind of ironic that it says Java, even though we're going to be using Kotlin. But remember, Java and Kotlin are interoperable, and also the basis of everything really is Java. So Kotlin actually is also on top of Java. So that's totally fine. And if we open our Android, if we open Java, we'll see that we have a few packages here. So a package essentially, it's just a folder that contains related classes. So all of these are different packages. The main package we want is the first one here, right? And it's very interesting also to see that we have the main activity, which is exactly what's opened. And then we have this UI theme, right? UI.theme. So this is all created for us. If you double click here, you can see that this is color.kt. So you can see color.kt holds all of the main colors that are used in our project. And you can see if I go to my theme file, double click, let's just see code, you'll see that somehow you can see that this is actually where the colors are being used. You see here we have a val called dark color palette, and we have dark colors, and we're passing, in this case, the primary colors, primary variant, and so forth. And we also have the light color palettes. Now, this dark and light color are used for different modes, for different UI modes. We have dark mode and we have light mode. So nowadays, devices can be on dark mode or light mode. So right off the bat, our project gives that flexibility of dark and light mode, and the colors that will be shown in one of those modes. And then we have this type. What is this type? Well, type here we have a few things. This is where we can set our typography. So talking about styles, fonts, and sizes, and so forth. There's a lot of things here, but we have the basics set up. You see here it says typography. The body is set to this style, okay? Which means if we want to use, for instance, we are in our main activity, we want to create a text, and we want to pass, let's say, a style, we can use this typography here, right, variable, and invoke the body to get the body style for the text we want to show. These are preset values, and obviously we can change those, as you see here, other default text styles to override. We can override all sort of things. So this is something that we're going to take a look later, obviously. All right, so, and we have shape. So for shapes here, we can actually use certain predetermined shapes for our user interfaces, for our widgets, as we create them in our main activity or anywhere else in our application. So we can create our own, obviously, but there are a few that are set as a default for us to use. As you see here, I have val shapes, and we are getting the shapes. As you can see here, if we get a small, we're going to get a rounded corner shape of 4 dp, which means if we use, for instance, a card and we want to have those rounded corners, we can right away say we want small. This is the value we're going to get for our rounded corner shape. For a medium, this is what we get, and large, that's what we get. Right? So all of this is given to us, and we can always override and customize. And of course, we have our resources folder here, and then we have our drawable here in our resource files. Okay, resource file, and then inside we have this drawable folder. This is where we can add images and so forth. And we also have the values folder here, where we have colors.xml. These are also the same representation of the colors that we saw earlier, that it's used still in Android development. Okay, these are still used, of course, internally, because remember, even though we're talking about Compose, we're not saying that everything is stripped away in terms of how we used to build Android applications. This is just a quick overview of what we have here, and I do realize if you're an Android developer already, this may be very mundane to you, and you can always fast forward or skip this, but it's fine. But I just thought it would be good for everybody to actually get at least some idea of what's going on here. All right, so we will be spending a lot of our time in this folder here. So in our main activity, because we are creating a Compose project here, this is what we see. Let me go ahead and close this down. Now we can split between code, just code, and split to see here the preview. If you refresh, we should see a preview in a second. Okay, after a few seconds, you can see now it says here, hello Android. Now, it's important to know exactly where is this being previewed from. Let's look at our code. You may think this is being previewed from here because this is where it's being called, but that's not true. If we go down here, we can see that we have this default preview. In fact, we should have a hint here that says default preview. So this is indeed the name of this function here. Okay. Now it's very interesting to also keep in mind that every composable function has to have this @composable annotation. So annotation is a way of adding meaning to certain functions or classes and so forth, to add metadata, to say so that the compiler can know exactly what to do. There will be more directions as to what is it that it's going to be added onto the function or class that is being annotated. That's the idea. Although in Compose, the @compose is not necessarily annotation as you would have in any other circumstances, such as in Java and even Kotlin in a sense. So look at this as more of a keyword that tells the compiler that, okay, this is indeed a composable function, which means it should construct a piece of a user interface. But again, what is really making this available here in our preview is this @preview annotation there. And you see also, if you hover over anywhere, we get some documentation. This is really important and cool. So if whenever in doubt you don't understand is, for example, what this is or what something is, you can always hover over and you have a preview. You can see here it says this is a public constructor preview. Very good. That means we can pass all of these parameters. And you can see one of the parameters we pass is show background to boolean to true. What happens if I say false? Let's test things out. There we go. If I say false, then we lose that white background. All right. Back to true. And if you preview again, or actually hover over, I should say, the preview, you can play around with anything else that you want here, like a name. You can change the preview name to something else. I can say, for instance, name is equal to me, like this. And voila. The moment you do that, you can see it changed to me instead of default preview. So if you don't put anything specify, it's just going to go and get the name of the function. Let's rebuild again. Didn't have to do it. You can see it says default preview. Okay, so and next you can see here we have the intro to Compose theme. This intro to Compose theme, you notice it will take the name of the application that you created, that you typed in when we were creating this project. Right? So what is this? Well, it's a pendant theme, so you could imagine that this is theme related. If you hover over again, you can see that this is @composable, which means is indeed a composable itself. It says public fun and intro to Compose theme. And then here you can see that we can pass a few parameters. Okay? And these parameters are optional, at least the first one. So the first parameter is dark theme. So it expects a boolean. So as the name implies, dark theme will allow us to say, okay, we want this to show in dark theme mode or not. And then we have this content here. The content is a composable function that is expected here. Interesting. And the beauty here, because you remember, if you've been following us, or if you remember your Kotlin, you remember if you have a function that has a function, another function as its last parameter, which is this case then, that means that we can use a lambda. As you see here, we can use a trailing lambda to invoke this content last parameter function. And of course, it's expecting at composable, which means expects any composable function to be shown or to be added. So in this case here, that's why you can see we have greeting, which indeed is a composable function. If I remove this composable there, we can have a lot of issues, because you're going to say, well, function which invokes a composable function must be marked with @composable annotation. So this is lesson number 1, to say that you can only call other composables inside of composable functions. Very good. So we're making progress here. We're going really slow because I really want you to get to know what we're dealing with in a very simple project. This is just a default project, a default Jetpack Compose function. So we're going to go through a few things here and keep digesting so we can wrap our head around Compose. Earlier, we were able to run this app onto our device. You can see here emulator, and it says hello Android. It's really small, I apologize, but believe me, it's there, and I know you're following along. You should see hello Android. And we said that we're able to change the color of the surface. The surface is going to enclose whatever is inside of our lambda, trailing lambda there. In this case, we are calling greeting, which is, you see here, it's another composable created passing name, and just text that says hello and pass that name. So hello Android is there. If you hover over our surface, again, you'll see that there's this parameter we can pass, or in this case, argument that we can pass, called modifier. A modifier is a very important one. So let's see how this works. So I'm going to say enter, and then I'm going to say modifier, as such modifier is equal, put a comma there, modifier, we're going to invoke modifier. And the moment we do that modifier, we can go and start invoking the methods that come with modifier. So in this case here, let's say I want to go and find fill max width. So the fill max width, what it's going to do is it's going to fill the max width that is available. Let's see how this works. So I'm going to go ahead and run this. I actually got the fill max height, not width, but you can see here is the same idea. So because I said fill max height, you notice that we have the entire height of the entire screen. If this screen was larger than this, it would have done the same thing. It would have taken up the entire screen. Obviously, we can do the same thing with the width, which is in first place. That was the first thing I wanted to do, but it's okay. This works. So how do we get to fill max width? Well, because the modifier, we can chain all of these calls. I can say enter, say dot again, because we're still in our modifier, right? I'm going to say fill max height, in this case width. All right, and there we go. If I run again, voila, now you can see that our entire surface, from not having anything, it was just constrained to whatever we had, in this case a text, now is showing, now is taking up the entire space. And what I can do also, I can continue chaining. I can say dot padding. For padding, I can pass all different kind of paddings, right? There are different functions with different parameters. But I want all to say all. In this case, named arguments there. I want to give, let's be exaggerating here, maybe 59.dp. I have to pass .dp because that is the unit that is recognized in Android. Okay, so 59.9 dp, that is how much padding I'm going to have around this surface. Is that true? Let's go ahead and run again and see. There we go. So we give 59 dp around the entire surface. When it said around, it is indeed around. So now you can see that the surface has shrunk a little bit, right? All sides by 59 dp units. So you can see by using modifier, you can modify, you can customize the views, the UI instantly and quickly. This is very powerful and we're going to be using it a lot. Obviously, I went straight to our set content, and in that case, to preview or to see the changes, I have to run, right? I could have done the same thing, obviously, here as well in our preview or inside of this composable or inside of this composable. It doesn't matter, right? But I just know that at the end of the day, if I want to push all of those changes so I can see in a screen, I have to put inside of our set content. It makes sense. This is where we're setting the contents of our app. Very well. So this is not a big project, as you can see. It's just a way for me to show you small things here and there so that you can still get the full idea of what Compose is and how powerful this is. Now, the main thing you have to understand here, I would like you to really take away, is that a composable function such as this, we didn't create this one, although it's very similar to this show age, but a composable function is very powerful in so many ways. Number one, a composable function is annotated with the @composable annotation. So all composable functions must have @composable. That is not negotiable. So this annotation, what it does, it informs the Compose compiler that this function is intended to convert data into UI, because that's all we're doing here. A Compose function converts data into UI. What this means is that this greeting or this show age, doesn't matter, but this greeting here, what we do, we're passing data, right? That's all we're doing. And this data is actually being transformed or converted into a user interface. Voila, you see there, hello Android. That is the power of a composable function. That is the power of Jetpack Compose, ladies and gentlemen. Because a function takes in data, the composable functions then accepts those parameters, right? We can pass as many parameters as we want and accepts it, and then we can do something. In this case, we're calling yet another composable that we didn't create. However, it's a composable. It's got a lot of parameters passed, arguments that we can pass to also set it up and transform this into an actual user interface widget. So this is the thought process, how you should start thinking about Compose. If you're coming from, for instance, Android development, the imperative way of Android development, where you have XML and then you have the Java class or Kotlin class, and then in activity you use a mechanism to get those XML UIs and then do something with it to give it logic, right? This is different. In our case here, now in Compose, we are converting data into UI. The other thing you will notice about composable functions to keep in mind is that since they emit UI, they don't have to return anything because they describe keywords here, ladies and gentlemen. They describe the desired screen state instead of constructing UI widgets. Here, we're not going through the process of constructing this text widget. What we're doing, we are describing what we want to happen. What we want to happen is a text to show hello and name that's been passed here. You notice also the naming convention. All of the composables start with uppercase letter. In any other case, if it's not a composable, you will start in Kotlin, especially in many other languages, you start a function name or a method name, as they may be called, with lowercase. That tells you something, the difference here. This is not a normal per se function. It is a composable function. It composes UI. It describes the desired screen state instead of constructing UI widgets. So everything you see to the right here comes from our preview. So any function that has @preview will be previewed here. That means if I come here and create another composable, we need to start @composable, and there we go. The ID was going to help us. Hit enter, and then I say fun, show age, for instance. In this case, I'm going to pass age, and it's going to be an integer type. And then here I can say text, hit enter. That's the first option. And all we want is the first one, which is just a simple text. So hit enter. And then here I'm going to say age, like this. Okay. Now we still may have the same problem. If you hover over, we're going to say, okay, some issues are there. Now the reason why I know what's going up here, if you hover over, it's going to say parameter age is an integer. But this text widget here only allows us to pass in a string. So I'm going to say to string for now, just to simplify our lives. Okay, so we have this show age. We pass age int. So essentially it's similar to this. Okay. So what happens here, if I want it to be previewed here, right, I can do so. How do I do that? Well, at the top, I'm going to say at preview, something like this. Now, we have a problem because it says if you hover over, it's going to say composable functions with non-default parameters are not supported in preview unless they are annotated with preview parameter. What this means is that, well, because we're saying age here, we say it's integer, we need to pass some sort of default value so that it's picked up in our preview here. So when you do that, you just say equals 12. And you can see this is gone. And now we can see it says show there, but we don't see anything. Let's go ahead and refresh. And voila. You can see, you see 12. If you click, it's going to go straight to where we created that text there. Also, you can see that we have this show age, which is the name of the composable function that we created. Now, because this is a composable, I could call show age inside of our intro compose theme as well. So at the bottom here, I can say show age. And of course, because we have a default value for age, nothing really happens, but I can say, if I want to, age 34 as such. You should see something here. Let's go ahead and refresh. And voila. Now, here's the problem. It's there. I can promise you that it's there, but it's on top of each other. What's really going on here? Well, what happens is, because we're just passing inside of this intro to compose theme, there's no layout. There's no way that Compose will know exactly where am I going to put this. So what happens is that it just puts things on top of each other. So if you really want to see what's going on, we can put inside of a column. So column will always put things on top, will always put things vertically, right, below each other. So I'm going to say column, start typing column as such, and you can see this is indeed, of course, another lambda. Everything is a lambda, and we can pass all modifiers and so forth here to structure our column. But for now, it's okay. We're just going to go and put all of these inside there. Let's go ahead and refresh. And just like that, now you can see that we have hello Android and 34 because we put that inside our column, which is going to structure everything vertically. Again, if you want to know more about a column, you can hover over and you can read all of this stuff. Okay, so now what is up here? Let's look at the set content. So the set content here, as the name implies, this is where we're setting the content so that it can be viewed on an actual device or emulator or so forth, right? So in this case here, we can see we have a main activity, inherits from component activity, we have on create. So this is the entry point to our project. So here we're setting the content, yet another lambda, and we're passing the intro compose. Remember this guy from down here, right? Same guy, same thing, right? It sets up the entire view according to the default theme, okay, of the project. And then another compose, we pass inside here the surface, which is another compose. Okay, which is not a compose, and it has also training lambda. So everything is about lambdas here. Very good. So here it says a surface container using the background color from the theme. So a surface is just in the most primitive, the most basic canvas. And as you can see, we can pass a few arguments here, color, and we set the color from our material theme that we saw before. We go to colors and we get the background. Okay, and that's where we're passing greeting Android. So this is going to be called when we run this app on the emulator. So if I go ahead and run this app, make sure you have, of course, an emulator. So the idea is that when we run, we should see this greeting Android. Okay, you can see after a few moments, you can see hello Android. So whatever we pass here inside of set content, it's not going to be in our preview, right? So the preview is to preview whatever we're doing. We're calling greeting, the same thing that we see here. It's for us to preview. We're also calling another composable that we created at the top there, which incidentally also has preview. We can remove that preview if we wanted to, and so forth. So whatever we pass here inside of our set content, it is indeed what we see there. The beauty also here, let's toggle the code only, is that if I set a different color, let's say I want, say, colors, and let's see what else. I'm gonna get, let's get primary to see what's going to happen. Let's go ahead and rerun this. And you can see now the background of our surface, which is this, right? That's enclosing our greeting, which is what we have at the bottom here. It's a composable. It changed the colors now. All right, so here's what we're going to do next. We're going to create a very simple application where we're going to have a button of some sort or tappable UI widget. And when that is tapped, right, this circle is tapped, we want to increment the amount of money we'll see at the top there. So it's a very simple app, but it will give us some insights into Compose and how certain things work. All right, let's go ahead and get started. So back in our project, let's clean things up. So there are a lot of things that we no longer need. In this case, I'm just going to get rid of all of this. Okay, and then get rid of this. So just for testing purposes, I'm going to get rid of this composable as well, which means this needs to go. We can't do that anymore. Okay. All right. So the first thing I'm going to do here inside of our set content, we are passing, of course, the compose theme, and then we have a surface we talked about is taking over the entire screen at this point because we have max height and max width. We add some padding, and at this point, let's just get rid of that because we're not going to need that. Of course, then forget our comma there. Okay. Now, one thing I want to do is, in fact, let's come back. Now, one thing I want to do is I want to remove this surface outside into its own place. So I'm going to create another composable here. So say add, space, add composable as such, say fun, call this my app. Okay. And then for this my app here, what I'm going to do, I'm going to get this entire surface there. Okay, this is going to be our canvas per se. I'm going to put it here as such. Okay. And then for now, inside here, let's just say text and say hello. Okay, and I'm going to call my app, of course, inside here, my app as a composable. Very good. And then also my app here. So this is just a very simple way of organizing our composables. So we want to have it inside here because we want to be able to see in our preview here. So I'm going to go ahead and refresh. And there you have it. So we get what we are looking for. And the other thing you see to the right, bottom right here, we can actually toggle the percent. We can actually toggle the views here. I can maximize, so zoom in, or minimize, zoom out. So in this case, if I go to click the zoom to fit screen, click here, you can see it's going to go ahead and zoom to fit this real estate we have. Okay. All right, so we have everything looking good. So there's the color, primary color, because that's what we chose. The other thing I can do, if I want to, for instance, add a customized color, I can get rid of this and I can invoke color, class as that, and pass in its constructor, I'm going to pass the code that will represent a different color that I want. All right. So to pass the hex code as a to pass a hex code here, which will represent a color, the first thing you have to do, you're going to say 0, X, and then I already have the color, so I'm just going to, and then I already have the color somewhere. I'm going to find it, and I'm going to add it there. The other thing I'm going to add, I'm going to say FF to begin with, like this, and then the actual color, okay? Oops, like this. All right, there we go. So these colors here, it doesn't matter really. You can put whatever you want, but I just found that color to be great. So I'm going to go ahead and refresh this real quick to see the differences. Okay, so there we go. We have that very nice color there. Very good. So that was a test. I'm going to get rid of this and continue. Now, the next thing so what is it I want to do? First of all, when I create a circle inside here, there are different ways to create a circle. So I'm going to create yet another composable here. Say at composable as such, and call, say, fun. I'm going to say create circle like this. Okay. And inside here, I'm going to create a circle. How do I create a circle? Well, as I said, there's different ways, but the basics is that we need to have some sort of the baseline, or we have to have some sort of a main composable we can call, and then we can modify it. So let's start with a card. So I'm going to say a card like this. So it is a composable. Hit enter. And for now, also, I'm going to go ahead and make this previewable, so that way I can also preview to the right here. So at preview as such. And in this card here, if you hover over, you will see that there are a lot of arguments that we can pass. Most important one, we have this modifier, and we have the shape, background, and so forth. And one thing that is very important, the order in which these are added is very important as well. Okay, so let's start with modifier, because it will allow us to modify, as the name implies, our card. Okay, so inside here, I'm going to pass, say, modifier as such, and the ID will help us. Just hit enter, and then pass modifier, and then we can call whatever we want. We can use padding. I just put 3.dp, right? And I can chain our modifier as I've shown you before. So what I want to do is, for instance, I can say dot background and give a color to the background. All sort of things. But the other thing I want to do, I will stop with the modifier for now. If I hover over here, there are other things we can pass. The other one is shape. What shape do I want this to have or to take? So I can come here, put a colon or comma, I should say, and I'm going to say shape. Now there are different kinds of shape we can pass. In this case, I'm going to just say circle shape as such. So this card as it is right now, let's go ahead and run this or refresh. Let's see what's going to happen. You can see it's very small. There is the card, right? It doesn't have much because number one, we don't have a size, and it doesn't even show the circle shape. Let's see something here. If I come back to our modifier, say dot, I'm going to say width as such, and you say width, and also there is height. So we can specify the width and height. But there's also another way of doing this. I could also pass this size. So there are overloaded size functions here. We have this size here. You can see we pass just one size, right? If you pass that one size, that means it's going to take up for width and height. But you can specify size for width and height. You can specify size in and so many. Now let's go just to size and say I want this to be about 45.dp, okay, as such. Let's refresh. And just like that, ladies and gentlemen, you can see we have our circle. Very good. So again, because of modifier, we say padding is going to be about 3 dp, and the size is going to be 45. So the smaller the size, obviously, the smaller the circle is going to be. And we say the shape of this card is going to be circle shape. This is given to us. I can also say rectangle shape like this. If you go ahead and refresh, you should see rectangle. And voila, you can see there it is. Now the reason why it's square, it's not a rectangle per se, is because of the size that we gave. We gave 45 for all of height and width. That's why we have a square. Okay, very well. So let's go back to circle, what we had before. So inside of our trailing lambda here, that means we can add the contents that we want to see inside of our card. So in this case, I can say text like this and say tap like that. Let's refresh. And you can see we have tap showing there. But we have a problem here. The tap is not in the middle. We want it to be in the middle of our card. Now, there are different ways to deal with this issue. One of the quicker ways we have here to force the text we have here to be in the middle, is to wrap this text into a box, because a box will have a parameter that will allow us to set whatever's inside of this box to be in the middle. So what I'm going to do at top, I'm going to say box, and there we go, the first box there, and I'm going to get all of that and put it inside. And if you hover over inside of a box, it is indeed a composable. Everything is pretty much a composable in Jetpack Compose. And you can see we have modifier as the first parameter there, and we have the content alignment. This is really good because it will allow us to align the contents inside of this box, which in this case is the text. So I'm going to say content, start typing content alignment. It expects an alignment object, so say alignment, and there are different objects here, or different variables that we can pass. So the alignment we want is the center, okay, not top center. We want just the center as such. If you hit enter, and voila. Okay, there we go. So let's see if this is true. If I refresh this, I should be able to see tap now in the middle. So tap is now in the middle of our circle. That means if I make this a little bit bigger, you can see it doesn't matter how big or how small it is, our card, in this case, our circle, it's always going to be in the middle. Okay, there we go, and voila. Nice, so we're able to put tap in the middle of our card, which in this case is a circle. Now, we want to make sure that this tap here, or actually this whole card, when it's tapped or clicked, something happens. So we want to make this whole composable, this whole widget here, clickable. How do we do that? Because remember, this is just a card. If you hover over, you see there's no on-click event that we can pass directly. But here's the thing. Because of modifier, we can actually invoke a clickable event. Look at this. If I say dot clickable, I can make anything clickable. If I hit enter, you can see now we have another trailing lambda. Here is where we actually add the event. Here is where we capture the clickable event. In fact, if I just come here and I want to log out just for testing purposes, I can say log D. You can see we have an option now of creating a log. Hit enter, then there's this code completion. So for log D, for log debug, we need to pass here a tag. I'm going to say tap like this, circle is there. I'm going to say circle tap like that. So now if we run this, we should be able to, when this whole entity, this whole widget is tapped, we should get this message. We can also deploy this specific preview here onto device by clicking this button there. So right, click there actually. Let's look at our emulator and we should see, hopefully soon, something. Let's go ahead and just go to code so we can save some space. Okay, there we go. It's very small. I can make it this a little bit bigger so you can actually see. Very, very small, but there it is. Now let's see if this works. I'm going to open logcat and I put tap here for our regex. So if you tap, you can see it says tap there. So each time you tap, it's going to show. Okay. You can see all of the taps are being shown there. All right, so it's working. All we had to do is just to, through our modifier, to say we want this card to be clickable. And when that happens, we want, in this case, a message that says create circle tap, which is exactly what you see. Okay, so as you can see, when we run it, it's really small. We want to make it a little bit bigger. Let's maybe make this 105. There we go. It's really large. The other thing we can do, because it's a card, if you hover over again, you see we have this elevation. So this elevation, what it will do, it will elevate the button so that we have a contrast between the button and the background. Because as you see here right now, it's very minimal, the contrast. So I'll hover over to make sure we know exactly where that. So anytime after our shape, we can add elevation. So I have a modifier there, and we have shape. I'm going to just put here at the bottom, I'm going to say elevation, and give it about 4.dp like this. All right, let's go ahead. We can stop this if we want it and go back to split mode and make this that size. And let's go ahead and refresh. We should see some differences there. All right, there it is. It's hard to see. Let's go ahead and just run all together on an emulator. Hopefully we can see. Aha. Now you may ask, okay, what's going on here? Why is that we don't see anything on emulator? Remember earlier we actually created or clicked deploy preview, which just deployed this, not necessarily the app. So that is the distinction. Another thing here, you remember that we're still constructing our circle here, and we have in a preview mode for this create circle. We're not calling it anywhere. So if I call it inside of my app, because remember my app is being called inside of set content, that should work. So here I'm going to say create circle like that. Now if I run, I should be able to see that circle. Ah, there we go. There's our circle. The circle is not what we're expecting, but it's okay. We'll fix that. So what's happening here is that because in our my app here we have a surface and we are saying fill max height and fill max width. So the circle now is taking up the entire space because there's nothing else inside of this surface. We'll fix that. But nonetheless, you can see now that there is a distinction between the background and the button because we added that elevation here. So the bigger the elevation, the more contrast you will have. Okay, you can see at the bottom here, actually it's probably better, there's some sort of shadow happening there. Okay, now if you click, you can see now this will work. If you go back to logcat, you can see that tap has been working. Each time you tap, everything still works. All right, so next we need to tackle this problem we're having here, which is it's taking up the whole space, which is exactly what we told the surface to do. But that's not what we want. We want the button to hopefully be in the middle of the screen. So I want you to think about this. What would be a way for us to make it so that this button is in the middle of the screen? So let's solve the issue we have here. Our card, our circle per se, is taking up the entire space in our surface, which is not what we want. So what we can do actually, and this is going to help us because in the long run, that's what we want to do in a way, because we want to make sure that we have another composable, in this case, another widget on top here, right? What we want to do is to wrap our circle inside of another composable, okay? So what would that be? Well, that composable is going to be a column. We want to be able to have widgets that are from top to bottom, that are lined up vertically. What I can do really here is I'm going to put inside of a column because that's what I need. Hit enter, and then we're gonna get our friend here. If you just say command shift and arrow up, control plus shift plus arrow up on Windows, it's gonna take this entire line of code inside of column. Just like that, if I go ahead and rerun this real quick, we'll see that a few changes will happen. One important change, that is. And there we go. Now you can see instead of taking the entire space, when you put a column, it reduces the size to the correct size, which is exactly what we want. Now we still have a problem here. We want this button to be in the middle of the screen. In this case, it's going to be in the middle of our surface because this indeed is the outer canvas where everything is being laid out. So if you hover over again our column here, you will see it's a composable and we have that modifier. But most importantly, we can now align things vertically or arrange things vertically as well as arrange things horizontally. This is really helpful because that means we have a lot of control of whatever we put inside of our column. So let's go ahead and say I want this to vertically, so say ver, what's that? Wait a second, vertical arrangement. So I can arrange vertically by passing arrangement like this. I want this to be center. So there are a few options. There's top, there's center, there's bottom, and so forth. So we're going to say center like this. And let's go ahead and run it real quick. We see what's going to happen. Aha, it is center. Yes. However, you see, we said vertically, we want this to be center. So vertically, it is indeed in the middle if we go top to bottom. But we also want to horizontally be in the middle. How do we do this? Well, we're going to go ahead and say horizontally. Let's add a comma there. Let's say horizontally. I said align. I want center horizontally like this. If we run this again, and voila, now the button is indeed in the middle of the screen, which is exactly where we want. Now remember, I'm passing inside of my app here, which is being called in our set content. And my app, as a composable, we have a surface, and inside of this surface, this is the surface with this color. Inside of the surface, we added a column, and we made sure that everything or anything that is inside of this column is going to be vertically arranged center and center horizontally arranged horizontally. That's what we get there. Very good. And of course, inside of our column, that's where we create the circle. We call create circle, which is indeed this composable here. And right away, you can see that indeed we have everything in the middle as well, right? Because we just previewing, we've now passed the my app, which contains the surface, and we're passing, there's a column there, and then we call in the create circle. And there you have it. So next, what is there we want to do? Well, next we want to pass at the top here. What I can do actually, I can go straight and put a text, right? And this text here will say what? Well, I want this to say hello. And this text here, I can say text. Now, there's another thing to notice, very interesting here, is that we can actually pass named arguments here. And it's really a good idea to pass named arguments, because especially when we start passing a lot of arguments into our composables here, things get a little bit chaotic if we don't add these named arguments. Okay, you don't have to. In fact, you can just go ahead and just say something like this, hello, and that still works. But it's a good idea to always pass the actual argument name, something like this, and then pass the values, the data in this case. So for now, I'm just going to go ahead and say 100 like this. Of course, this is going to be inside of double quotes. Oops. Let's go ahead and refresh. And there we go. So it's hard to see, but there it is. And we have our tap button, which is a button now because we made it clickable. And then we have the text there. Now imagine that we want to put some sort of space between this circle and this text. How do we do this? Well, there is a specific composable that we can use called spacer. Like I say, spacer like this. Again, you can pass a modifier. The modifier in this case could be a few things. So I'm going to say modifier. Let's go ahead and just type it all out, modifier. And because I want the height of this modifier, and because I want to make sure, let's go back again here. I want to make sure that the height, right, between this widget and the next one, there's some sort of separation. So the more height I have, the more separation I get. That's why I can then go say modifier dot height and give a value, let's say, of 30 dp. Let's refresh. And there we go. You can see there is that space that we need. So the more space we give, let's put 100, you can see the greater this number is in our height, the more space we'll get. So we have things set up as we want. They're looking really good. Let's go ahead and run one more time onto our emulator so we can see exactly how all of this transpired. There we go. We have our app is looking real good, but you notice that the text is really small here. We want to make this a little bit bigger. How do we do that? Well, funny you ask, we can go inside of our text here. If you hover over again inside of our text, remember this is still a composable function. We can pass, of course, the text. We pass the string. There it is. But we can also pass other arguments. That's the beauty, again, of Compose here. Of course, we know we have the modifier, our good friend. We can pass the color, font size, font style, and so forth. But you see that the last one we have here is style. This is more free-form way of styling our text. I'm going to use that so I can show you. So I'm going to say, comma, I'm going to put style, and we can pass a text style type. I can start saying text style like this, and you can see we have text style default and many other. We have there's text style, and you can see if I hit enter, inside of a text style, we can pass all kinds of arguments. Oh, this is beautiful. So we can really customize our text to our liking. Look at all of this, all right? So in this case here, I can go and change the color. I can probably say, put enter, a new line. I'm going to say color and set color. I'm going to use this color here, and then I want this to be white. Okay, and then I can say option space, and then I can say font size. All right, for font size, I'm going to say 19, and now I'm going to use a different unit, which is SP. Okay, so whenever you want to use font sizes, SP is the recommended. So I'm going to say Alt or Option Enter to import SP library. There we go. And now if I run this, there we go. It's 100, still small. So we can play, let's say 39. That's much better. Okay, because we just change a style, an attribute here. You notice that we didn't have to rerun everything to see the changes. So this looks great. Maybe 30, maybe 35. Can play with this forever. Okay, so there we go. It looks really good, and we can make it bold. I can say font weight, and then I'm going to say font weight, and then go get bold. The other thing I can do, I can start typing bold like this, and the IDE will actually give the option for bold or extra bold. Let's say extra bold because we're feeling extra today. Okay, let's go ahead and run this. Okay, there it is. So we were able to put together this user interface. Okay, so it's very simple, but at least it's going to guide us, understand how things will work, how to compose, no pun intended, how to compose a nice user interface as you see here. Now, obviously, the whole idea is that we want to make sure that when we tap, as we tap this button, we made this a button, it's just a circle. We want to increase this number here, right? We'll start at 0 and go from there. And that's what we're going to be doing in the next video. So what we want to do next is to be able to go to our circle or create a circle. You can say Command Enter to go to the definition, or Control B on Windows, as you can see at the bottom here. And so what we want to do is when the circle is clicked, we don't want it just to show what we see here. We want to be able to do something. Ideally, we want to be able to increment this value here. So let's test things out first. We want to be able to increment a value, which means we need to create that value or that variable. So let's go inside, still inside of our function here, outside of our card. And I'm going to initialize a val. Let's say money counter and set that to 0. That's the first initial value, okay? And so here, what I can do, I can hopefully say something like this. Money counter is equal to money counter plus 1. So each time that we click on this money counter, we are going to increase it. But of course, I'm going to have an issue because, of course, I said val, but this should be var, so that we're able to mutate this. So this is immutable. So if you have val, that's going to be immutable, meaning we can't change it, but var will change it. Makes sense because we need something that changes. And we still have an issue here, or rather a warning. So let's have over and see what's going to happen. It says here replace with operator assignment. So yes, let's do that. It's smarter this way. Either way would have worked, but this is succinct and the way we should always do it. Okay, let's run this. Actually, before we do that, let's go ahead and say log D again, because we want to see in our console this value. So I'm going to go ahead and say my counter to see if it actually changes anything. Money counter, that it is. Okay, and just going to say counter. All right, let's see. Let's go ahead and run. Let's go ahead and also open our console there. And I'm going to say I'm going to look for counter, right? So we can see the results just for counter. Okay, let's go ahead and see. All right, so I keep clicking and I don't see anything. Maybe I missed something. Let's see. Is that true? Okay, let's see. Counter. Okay, that's nice. Circle 1. And it works fine. Okay, because we can see as we tap the values being incremented. That's fine. Now let's see something else here, because the idea really it's not to log these values. The idea is to hopefully see the changes somewhere in our UI. Let's change, for instance, this tab. Instead of saying tab, I'm going to attach another variable here. In this case, money counter variable. Let's see what's going to happen now. So I'm going to go ahead and leave that as it is. I'm going to run this. So the idea is that as I tap, I should see money counter also going up, just like we saw here, right? Let's wait for a second. Okay, let's try again. Click. We notice that the counter works fine. 2, 3, and so forth. However, when it comes to changing our text here, you should say tap, also incrementing, right? First 1, and so forth. This tap money is the same variable that we are showing in our log here. Yet in our log, it's going up, but the moment we attach to a composable, a UI, a piece of UI here, UI widget, then we don't see that change. What is happening here? Well, this is an important concept that we really need to understand in Compose, which is in order for us to see changes in our text here, or in this case, in any other composable function, as you see here, this is not going to do it. The reason being is because whenever we want to change something inside of a composable function, in this case a text, right, we need to redraw that composable, which means this text here has to be redrawn with the new value. And if you remember correctly what we talked about between the difference between the imperative approach in Android development versus the declarative approach. In the declarative approach, we are passing data through the composable functions, and then the composable function reacts to that data. That's the idea. So how do we make this to react to that data, which in this case mean to rerun itself, to redraw itself? By the way, this redrawing itself, it's called recomposition in Compose, and we'll talk about that in a second. For that to happen, there's a special variables that we need to pass here, or we need to create for this to happen. This special variable will create what's called an internal state, because we need that state so that we can control that something has changed. That way, this composable text here will know, oh, my data, money has changed. That means I have to redraw myself, recompose myself to show that new change. Interesting. That means then, in our case here, what I will need to do, I'm going to say var money counter. I'm going to use delegation here. I'm going to say by, to delegate this responsibility to some other class we don't even have to know about. I'm going to say mutable state of, like that. And this mutable state of, I'm going to pass a value of 0 in the beginning. So what are we doing now? We are saying this my counter is not going to be just an integer. It's going to be something that is wrapped into a state which is needed for us to be able to, obviously here, to recompose our text so it gets the correct value as the value is changed. Obviously, so we're going to have some issues here because we need to import a few things. So just hover over like this. You can go ahead and import, or you can just say Alt or Option Enter. It's going to start importing everything that we need. We imported that, but we need to keep importing until that it's not read anymore. Now we have another problem here. If you hover over, it's going to say, okay, creating a state object during recomposition without using remember. So that's another concept here that needs to be addressed. The idea is that when state changes, obviously the UI must also change. That means then we need a way in which this function here, composable, will always remember the state. So that's what's happening here. So we need to actually say something like this. So I'm going to say here by, and then start writing here remember, like this, hit enter. And remember is a lambda. So now we're going to take this mutable state of, just put that inside there. So what we're saying now is that, yes, we are going to create a mutable state of, and we pass the value here. The init value is 0, which will be implied to say this is indeed an integer. And then we're going to have to remember that state. And all that is going to be, and we are going to put all that value inside of my counter. So now this no longer is just an integer. If you hover over, it says my counter is an int. However, we wrapped it inside of remember as well as a mutable state, which is really important. So now if you use my counter, things are going to work. So now let's see if this works. I'm going to go ahead and run this. Okay, let's see if this is going to work. Remember, I still have counter here on debug and it's open. If I click, and you can see, make this a little bit bigger. You can see now tap is 1, 2, and is working as intended. So what's happening here, because we have that state attached to my counter and it's being remembered, what's happening now, the text will know that, okay, this is being changed the moment that we click. Since it's being changed, the value is changing, and I will remember that because it's a remember, because we have a state and it's going to be remembered. What happens now, this is being recomposed, meaning it's being redrawn again each time that this value is changing. That's why we're able to see what's happening here, 10 and so forth. And just now you've learned one of the most important concepts in Compose, which means we need to have a state for us to be able to see changes, to update a user interface. In this case, this text or any other composable function out there. So you see the difference here is that we have data and we pass that data through our widget, in this case our compose function, and then that's when the compose function will then come to life or will update itself, because it will know now it's time for me to update myself because I have new data. And that's why this is working now. Very good. So now we're going to take a little break and go and understand a few other concepts that surround this one concept we've learned, right? We need to understand a little bit more how this recompose, because I've talked about recomposition and so forth. What is it and how all of that works? And then we're going to compare again the imperative approach versus the declarative approach, which is what we're using here. Now let's look again at the imperative versus declarative approach. But let's dig deeper so that we really understand what's going on or why Compose is really great at what it does. So in the imperative approach of Android development, so you would have Android layouts. So you have a lot of views that you put together to create a user interface, which means that you have two sections going. First is going to be the layout file, which is usually in XML, and then you would have an activity, right? So in order for you to be able to traverse or to be able to go and get, for instance, a view or in this case, a widget, could be a button, a text, or an image or so forth, in your code, in your activity, you would have to use functions such as find view by ID, right? So what are you doing when you say find view by ID is that you're traversing this tree that is created containing all of these widgets in the background, which, as you imagine, takes time and it's expensive in a sense that it takes a lot of memory, a lot of computing power. So one of the things that also you have to remember is that in order for you to change, let's say, a text view, you would have to use getters and setters. That means you have to say text view set text to a string or a button dot on click and so forth, right? So you actually have to manually change the state of the views. First of all, you have to traverse the widget tree, which is very expensive. It takes a lot of computing power. And also it increases errors. because it may happen that the view you're trying to find has been long removed by another function, by another class. So now you are looking for something that doesn't exist, or if you are trying to update something that doesn't exist, then you end up with a lot of errors and your app may crash. And also, as I said, you are directly changing the state of the widget manually. When you say text view .set text, you are directly going and changing that state of that text view, which is not a great thing because it pollutes your whole state management of your app, and you wind up with a lot of issues, and you potentially may wind up with a lot of problems. So this is the imperative approach. And the fourth pitfall is that you may end up with also update conflicts. So update conflicts may happen for the same reason I said. You may try to update something that was already updated, and now this state is all messed up because there isn't really a one source of truth when it comes to state. All of these are some of the pitfalls we get from the imperative approach of Android development. Now, when we go to the declarative approach, in this case Jetpack Compose, things change dramatically. The same idea we have, right? So we create views. In this case, we create declarative UIs, right? Which means now the UIs are built and updated differently than before. What happened now is that when something changes inside of our widget of tree, in this case, all of these composable functions or widgets inside of your app, what happens is the system goes out and updates the screen, but most importantly, goes and only updates what needs to update, the widget or the function that needs to be updated only. This is what we call recomposition. The beauty here is that we no longer have to manually update each widget. So you remember the text view that's set, we no longer have to do that because we're declaring what we want to see and we're letting the data dictate whether that view needs to update or not. And also, most importantly, we no longer rely on XML to create user interfaces. Now everything is done in one way using one language, in this case Kotlin. Another main concept in the declarative approach is that data is passed down. What that means? Well, in other words, we pass data into our main composable, and then the other inner composable functions, in this case, in return will react to it, which means they will update and describe the user interface as they see fit. So now we have smaller composables functions that are waiting or receiving data and be reactive as they get that data. That's really, really powerful. And on the other hand, on the other side too, what happens is that events go up. What that means is that an event is triggered. For instance, if a user interacts with, for instance, parts of a story widget, as you see in this diagram here, what happens is that the app logic will know that there is an event that is happening here, and it will know whether it is a new data that's being posted, that's been sent out. That way, other parts of our user interface, right, other composables, will also be notified that, oh, something has changed. We need to do something if necessary. Again, that recomposition is happening here. Remember, if necessary. That is the most beautiful thing about Compose, is that it does not go around and compose and recompose, I should say, all of the functions. No, it just goes and picks the one that needs updating. Now we got rid of all of the clunk. We got rid of all the coupled situation that we had between layout XML and activity, because no longer have to go and set my data or the state manually using getters and setters and so forth. Now we're letting the data itself mandate everything, the data and the events. So this is the declarative UI model. Just because we need to have some sort of definition, recomposition is the process of calling your composable function again when inputs update. Is the process of calling your composable function again when inputs change. And this goes back or takes back to what we've been working on, which is that circle that we tapped. What happens, the recomposition happens because every time we change the state of our counter, the Compose compiler will know that, okay, just that text will have to recompose because the data has changed. Not anything else, just that text. All right, so let's go back to our code. Now that we understand at least the advantages that we have when using Compose versus the old way, quote unquote, of doing development. Now, there are a lot of things that I went through here, but I hope I broke them down in such a way that are easy to understand. And you are welcome to rewatch this video. That way you have certain concepts that are really, really important for you to really understand Compose, Jetpack Compose. So if things are not really making a lot of sense, don't worry, just to watch the video. And remember, we're still in the beginning stages of this course, so there's a lot to learn. And these concepts, I should say, they will come up over and over. And by the end of this course, I promise you, you will be good. You will understand all these concepts because you will have done a lot of work yourself to really understand how all of this works. But I want you to get this concept to change the way you think about development. Okay, so let's go back to our code. So back in our code here, we see that this is working perfectly fine. We can see that tap 9 or tap button is incrementing because we are recomposing and all the great things are happening. Now remember that you have, no pun intended, you have to pass the remember here, because the remember keyword can store a mutable or immutable object. So if values change, right, in this state here, it will trigger recomposition, which is the refresh of the UI, but not just the whole UI, but more specifically in this case, it's going to be targeted to this text here. Okay, this is what is changing, right? We're changing the user interface in this case by passing in our money counter data. Okay, so got to pass. We have to have a remember and then inside a multiple state of to create the actual state, and a remember will remember that state. Okay, now this is one way of actually creating a remember here, right? The other way is as follow. I can say var money c just to differentiate, and I'm just going to go ahead and say is equal to remember like this, and then just pick the second one, and then we can pass our mutable state of, and pass in this case 0. Now if I change the whole thing, let's just use that one. Let's comment out this money counter there. You will see that we have a problem. The reason why is because the way we have created this variable here, money counter, now we're not using delegate by here. It works, but we have to change a few things because now this money counter is not going to work because it's going to say if you have over, it's money counter, it's just a mutable state. It's not just an integer, but it's a mutable state. So we wrapped that into a mutable state. So what is a mutable state? Well, so a mutable state allows us to hold the state, right? It's just a wrapper that holds a state, but most importantly, these values are going to be able to send information, to send events. In this case, the compose function will observe this value. So all we have to do now is say dot and get the value. So it's a little bit more work, a little bit of code, but we're just going to say get the value of that mutable state. Okay, and here too we're going to have to say dot value like this, and if we run this we should see the same thing, but we've just changed the way we are creating these variables. Okay, now you can see everything still works the same, which is great. Now although everything works fine, we can tap and you can see the numbers going up. That's fine, but the whole idea really is to make sure that we update this 100 here, right? We have a counter here that we want, or text in this case, that it must update as we tap. And if you see, all this clicking is happening inside of create circle composable. So how do we then call that somewhere where we can then, in this case, be able to attach to this text here, right? Meaning this money counter here, we want to attach to this text. So essentially do exactly what we did here, right? This was just testing. We want to attach money counter to this text, and so we can see then money going up. How do we do that? Well, the first thing we need to understand is that we'll have then to remove this state here outside of our create circle. This is another concept called state hoisting, which means we are hoisting it. We are taking it up a level from where we are this state. So I'm going to cut this, and I'm going to call inside of my app like this. Okay, so we have a money counter, and there it is. But then, of course, this is not going to work here in our clickable because we have lost that. How do we then make it so that we're able to still interact, of course, with our clickable, right? Make sure that then this counter is still valid, meaning that we can still click and change this value here. Because now we have this huge disconnect, and you can see things are failing at this point. So first, what we need to do is in our circle, create circle here, we're going to pass a few parameters. So the first one is going to be money count, like this. It's going to be an int, just a normal variable. This is not going to work, so what I'm going to do, let's just, for now, comment all of that, and let's just call it here. Let's copy this, money count, okay? Let's go ahead and say Alt-Enter to remove the braces because we don't need those. Okay, so we're moving things around here. I'm just getting rid of this. And now we have an issue because we need to pass an initial value. Let's just say 0 so that the preview still works. Okay, so nothing works yet, but at least we have something. Notice our clickable is not going to do anything, but at least we know we have hosted our state up here. Okay, but the next thing we need to do also here, right, we need to pass some sort of a callback. So I'm going to say updated or update counter. It's going to be a function. Remember, we can pass functions as parameters, which is really amazing. The idea here is that we'll need to pass something into this counter, this update money counter function. What is it that we're going to be passing? Well, we are going to pass an integer because it's going to be what we're going to be updating, using to update, in this case, the counter. And this will return nothing. So it's going to say unit as such. Let's go ahead and close this down so we have more space. Okay. Again, we have an issue here. For now, let's go ahead and comment this out. We don't need to show a preview of this. Okay. So there we go. So now this update counter will expect what? An int, which is going to be the actual counter. That means then, if we go back to where this has been called, that means we have to pass a few things. If you have an over, it says no value passed for parameters update money counter. You can see here expects money counter, right? But because we passed an integer, also a default value, it's not required. But update money, it is. So that means then I'm going to pass my counter. What do we call? Let's see, counter. Money counter is going to be set to what? Well, we're going to set to money counter we created at the top here. Say money counter. Now, so it so happens that I actually named them. It so happens that I name both the parameter name the same name as our variable here, our mutable state. That's okay. In this case, I'm just going to have to go and say dot value because I need to get the value. Because remember now, this is wrapped inside of a mutable state. So we need to get the value, the actual int. Okay. Now, if you hover over again, notice that we pass here this update money counter, which expects an integer. Also, because it's the last parameter, that is a function, right, inside of a function, that means we can actually treat this as a lambda, which means I can just go outside and say braces, curly braces like that, and voila. Now you can see we have this int, or it I should say, which is an integer, which is going to be the number that's being updated. So here then, what I need to do is to, of course, update this money counter variable, which is a mutable state, right? Each time we click, we are going to receive that value, right? So here I'm going to say money counter. I'm going to say that value is going to be equal to the int we are getting plus 1, like this. And now, because we understand that this money counter here, it's going to be updated as a mutable state, so it's listened to states, I can change this to something like money counter.value, like this, and see what happens. Let's go ahead and run. And there you have it. The moment it starts, it looks at the money counter. It knows that the default value in this mutable state is 0. If we put 10 here, this would show here. Okay, now let's see moment of truth. If I tap, nothing is happening. What's going on? It looks like we haven't done anything in our clickable, right? We just comment things out and we still have this log. That's not what we want. What do we want to happen here? Well, here's the beauty. We have this callback here. That means then each time we click, we're going to say update, call this update money counter. And what we're going to do, we're going to pass inside here our money counter value, right? Because that's going to be the value that's been incremented there. That's an integer. So let's go ahead and run this one once again. So now if I tap, voila, you can see now it says 1 and keeps growing as such. And we still have this attached to tap. We can just remove that. That was for testing. Let's see, we run again. Okay, there we go. Now with tap, C1, and it's going to go and increment. There we go. And even to make it better, because we want to separate the concerns here, what I can do in our circle, we're passing, of course, my counter, which is going to be set to our money counter, which is a mutable state there. It's a state. Here, what I can do actually is as follow. I can actually change this because I want to change the naming. I can say, for instance, new value, right? And give it an arrow like this. So now what I can do, I can say our counter, money counter, that value is going to be set to our new value as such, which means then the updating or the increasing of the money will happen inside of our update counter. So I can say update counter +1 like this. So now we have set everything up the way it's supposed to be. And this var here looks like it's complaining. You can always say Alt or Option Enter. It's going to say change this to val, and we're going to do that. Okay, so there we go. So we've hosted the state to the calling, the composable, because my app is calling, in this case, this create circle. And then what we're doing here is that for a circle, we change a few things. We pass the money counter argument, which is going to take care, or is going to track what's happening with our money counter there. Okay, we get that value. And then because we have the lambda in our create circle, or we have a function that we call the update. Let's put this in a new line. This update money counter, and we're passing int. So we call that every time the button is clicked. We're going to call this update money counter. We're going to pass the money counter, whatever value we have here, and add 1 to that. That's exactly what's happening here. So it's going to look at money counter. It's going to be 0 at first. We're going to be passing that value into this, which in turn, we're going to set that value to the new value we're getting, which in this case, we are updating by 1. And now, my friends, we have created a very simple application. It does not a lot, but it really shows us this concept of state, which is very important, but also shows us how do we elevate that state to the calling composable. Now, why is it important to hoist the state? The reason why we want to hoist the state from our main composable to the calling composable functions need to be stateless, relatively stateless, which means they should not hold the state, right? Because we want them to be as flexible as possible. At this point, I can call this anywhere I want because it doesn't hold any state. We don't have this state here holding us up, right? So whenever I call, or whatever I call the create circle, I'll have to pass in the money counter and the update money counter function there. So we will delegate, we'll send the state to the parent composable, which will hold that state, and that will be changing itself there. And so the state is going to be changing, and then it's going to be propagated down to our circle, create circle, which then is going to go ahead and update the money. So there's a lot I threw at you here, and I did take my time to explain this because I want to make sure you really get this concept. Again, we will continue work with this, but I had to go slowly because I really want you to get this concept. Okay? And also remember, this is just the beginning of our journey here, so there will be a lot of opportunities for you to practice this. As it is, you can go ahead and practice this concept by creating, for instance, a counter, different counters and so forth, and see how this works. In fact, one of the things now you see that you can do, you can now, because we've hoisted the state, right? It's here now. We can do all sort of things with that state. For instance, we can say money counter, that value is greater than 25. I want to show a text that says lots of money, like this, right? Because we have that state and it's easy for us to do such. In the previous example, we wouldn't be able to do that because the state was inside of our create circle. Now it's no longer there, so we can do all sort of things, right? So let's see. If I keep tapping, okay, getting there, lots of money. So I hope this was helpful, and I'll see you in the next video. So in this section, we did a lot of things. The first thing we look at was the basics of Compose project and function, so that we can situate ourselves as we progress in our learning process here. And of course, we created a very simple money counter app, which the main idea was to show you how things are constructed, or how to put together a very simple application, but give you the foundation of how Compose works, how composable functions work, how you call composable functions inside of other composable functions. So how to simply structure your Compose applications. Okay? And of course, we look at modifiers, which is a way of us to customize our Compose widgets. And there's so much you can do with modifiers, and we'll continue obviously building upon this concept as we move forward in this course. We talked about basics, layouts, surface, which we said it is the most primitive traditional canvas that we can manipulate and use it to add other widgets on top, box and column and so forth. So we also learned that in Compose, you can make anything clickable, meaning you can respond to a click event, a tap event. Not only buttons receive click events, but anything really can also receive a click event through modifiers. And of course, we talked about state in Compose, which is a very important topic, because the whole idea in Compose is to make sure that we dissociate this direct tinkering or updating of the state of widgets directly, like using setters and so forth. So state allows us to do all sort of things, but mainly to decouple this dependency between the user interface and the logic. But the main goal really is to have one source of truth in our project through states. And with that, we really dove into the imperative and declarative approach, the differences and advantage of those. So imperative meaning the older quote-unquote way of creating apps in Android. And we learned that the industry now is favoring more a declarative approach. The declarative approach, you're declaring what you want to see on the screen, and let data be the reactor. Data being the thing that will allow the functions, in this case the composable functions, to react and to describe themselves as they're supposed to. So the data is the ingredient, if you will, that makes this declarative approach even better. We talked about state hosting again, which is a way in which we need to remove the state from a composable function to the calling function. That way we decouple the state with a composable, making that composable function more reusable and easy to manage. And of course, we had to define this very important aspect of Compose, which is called recomposition. Recomposition is the process of calling your composable function again when inputs change, which again is the whole idea behind a declarative approach. And the beauty of recomposition is that when that happens, we are only targeting, or I should say, the Compose compiler is only targeting the widget or the composable function that needs that recomposition, that needs to be refreshed, if you will. Anything else around it, if it doesn't need to refresh itself, it won't. It just targets the one widget or two, depending, that needs to change if data changes. Which is amazing, because now we are making sure that we don't run into memory issues, because recompose or refreshing the whole screen every time something change, it takes a lot of memory, right? A lot of computing power. And so the way Compose works with Recomposition, it makes it way easier and more memory efficient. Now, one thing I have to say that these concepts, this paradigm shift from imperative to declarative approach of building applications, it can be very daunting at first, or at least it can be very hard to grasp. Not because the concepts are hard to grasp, but because it's a shift of paradigm. It's a shift of way of thinking about building apps, right? So I encourage you to really take the time to watch the videos if you need to, because remember, this is a video course, which means you can watch as many times as you need. And really, if you hone in and understand these concepts, you're going to have a better time building Compose apps, because these concepts are the base of everything we're going to be learning now forward. Okay, I'm very excited, as you can tell, and I will see you in the next section. So I hope you enjoyed this video where I showed you around Jetpack Compose and how to put together something, an app in Jetpack Compose. Of course, there's more to Jetpack Compose. In fact, if you want to learn more about Jetpack Compose, I've actually put together a new course with 27 hours, I think 27 hours, or 29 hours, I should say, of Jetpack Compose. It's a full-fledged course. You will learn everything that you need to know about Compose. But not only about Compose, I also have sections on Kotlin, which is the programming language used in Jetpack Compose. Okay? If you're interested in our course, which I think you will love it, go ahead in the link below. Go ahead and just click on it and go and enroll in the course. It's going to be great. For now, thank you so much for your time. I really appreciate your time. And if you have any questions, comments, if you like this video, thumbs up and share this video, of course, with your friends, anybody that you think will benefit from all of this stuff, all of this content that I put out here. So thank you so much for your time. Well, I'll see you next time.